Hello students. So today I am going to start the second chapter of your chemistry part, that is acids, bases and salts. In chemistry part we already completed one chapter, that is chemical reactions and equations. So this is the second chapter of your chemistry part. A wide variety of materials having different characteristics exist around us. These materials consist essential of elements and compounds. So, in this chapter, we shall study the kind of compounds that we come across in our day-to-day activities. Some of are sour in taste and some of bitter and some are salt in taste. For example, lemon juice is sour in taste, soap solution is bitter in taste and seawater is salty. So one of the various ways of classifying these compounds is to group them into three categories. So that is nothing but acids, bases and salts. The properties of these compounds are different from each other. For example, acids are entirely different from the bases, whereas bases are entirely different from the salts. When we are combining acids and bases, we get a salt. So in this chapter we are going to discuss acids, bases and salts. Okay, see the what are the objectives you are going to be studying in this chapter. The first one is define acids, bases and salts. It means I have to define the three main important terms of the chapter, that is acids, bases and salts. Along with, you need to differentiate between the acids and bases. Next one, known uses of the common acids and bases salts. And next concept is define the indicators. What are the indicators and what type of the indicators we are going to use to identify the acids and bases, and some of the properties of acids, bases and salts. And next one, what do you mean by the neutralization reaction? And the last concept of the chapter is pH value. You need to understand the concept of pH, where we are going to be use the pH concept. Okay, let's start with the first concept of your chapter, that is acids. So the word acid is originated from the Latin word acidus. It is originated from the Latin word acidus. So acidus is nothing but sour. Acidus means, in Latin word acidus means sour. So the substances which are sour in taste are considered as acids. So few of the examples are given here. See the first one, vinegar, second one lemon and third one coke. So these are the some of examples for acids. Let's see the definition of acid. So how you can define the acid? In simple terms, we are going to define the acids like when an acidic substance is dissolved in water. If you are dissolving any acidic substances in water, if it releases the H plus ions, what it should be released? H plus ions. It should be releases the H plus ions. Once it releases the H plus ions, so that type of the substances we are going to be considered as acids. Okay, so see here, an acid is a substance that produces H plus ion, that produces hydrogen ion in water. When any acidic substance is dissolved in water, it always produces the H plus ion. It means hydrogen ion. According to the definition, proton, what it releases? Hydrogen plus ion, means it is the proton donor. So next one, it comes from the Latin word, already told you, no, it comes from the Latin word acidus, that means sharp or sour. And next one is, the more H plus ions, the more acidic of solution. It means when you dissolve any acidic substance in water, if it releases maximum amount of the hydrogen ions, then the solution is highly concentrated. Okay, see here. So acids, the substances that releases hydrogen ion in water are called as acids. Acids are the substances when it dissolves in water, it releases the hydrogen ions or H plus ions. So these type of the substances we are going to be considered as acid substances here. So this is the acid. When it dissolves in the water, it releases the H plus ion. Here some of the examples are there. So first one is vinegar. Vinegar is a one type of the acid. In vinegar we are having acidic acid. Lemon is also one of the source of the acids. So in lemon we are having citric acid. And next one, tomato is the best source of oxalic acid. Next, grapes are the sources of tartaric acid. And next one, milk and curd are having lactic acids. Next, ant is having formic acid. Apple, malic acid. So these are the some of the examples for acids. See some more examples with the sources of their organic acids. First one is citric acid. We already discussed in the previous slide. So citric acid. So what are the sources of citric acid? Citric fruits such as orange and lemon. Formic acid. Formic acid is sting of ants and bees. Acetic acid, vinegar and tomato. So these are the two most important sources of acetic acid. Malic acid, we are getting the malic acid from apples and grapes. Tartaric acid, grapes, right? Mangoes. So these are remaining, these two also the best examples of tartaric acids. Next one, oxalic acid. Oxalic acid means, what are the sources of oxalic acid? Spinach and cabbages. Next one, lactic acid. So lactic acid, the best sources of lactic acids are curd and milk. And vitamin C, obviously vitamin C is amla and citric fruits. So these are the some sources of acids. Now see in the next slide we are having properties. So what are the properties of acids? Mainly we are focusing on some of the important properties. First one is, it produces, already told you, when any acidic substance is dissolved in water, it always produces a hydrogen ion. It produces hydrogen ion in water. Okay, next one, they are sour in taste. And third one is, react with the metal, it produces the hydrogen gas. This is also important. Later we will discuss about this, how the acids will be react with the metals, metalloids, and next one, carbohydrates, oxides, bases. Okay, later we will discuss about that. Okay, next one, electrolytes. Electrolyte means acids, all the acidic substances are good conductors of electricity. All the acidic substances are good conductors of electricity. Next one, it reacts with a base to form salt. When acid is react with a base, it always form salt and water, salt and water. Okay, and next point is the pH value of acidic substances is always less than 7. It is always less than 7. And next, one more important point is acid turns the blue litmus paper to red. So how you can memorize this one? ABR. Just write ABR. Acid turns the blue litmus paper to red. So base will turn red litmus paper to blue. Okay. So ABR means acid turns the litmus paper from blue color to red color. Okay. And one more most important property is all the food components or food substances what we are taking that is having the acidic in nature. Okay. Next one is the classification of acids. We are classifying the acids in different forms. So here I am going to discuss few of the classification of acids. The first classification is based on the presence of water in the acidic solution. So see the first one, that is the classification of acids on the basis of presence of water, amount of the water which is present in the given solution. Presence of the water. On the presence of the water, we are going to be classify the acids as two types. First one is diluted acid and second one is concentrated acid. So how you are going to be classify as a dilute acid and concentrated acid? An acid solution may be concentrated or diluted depend upon the amount of the acid present in the solution. Concentrated and diluted solutions of acids are generally used in laboratories. Let us see what these acids. So how we are going to be classify as a dilute acid and concentrated acids? When the solution contains a large amount of the acid, it is said to be concentrated acid. For example, see here, concentrated acid. Acidic solution which has a small amount of water and large quantity of the acid is called as concentrated acid. What happens in concentrated acid? In concentrated acid we are having only less amount of water and maximum amount of the acidic substance is present in the particular solution. If minimum amount of water and maximum amount of the acidic substance is present, then that type of the solution we are going to be considered as a concentrated acid. Now see the diluted acid. Diluted acid is exactly opposite to concentrated acid. What happens in diluted acid? See the definition. Acidic solution which has a large quantity of water and small quantity of acid is called dilute solution. It means here in diluted solution we are having very huge amount of water and very less amount of acidic substance, So these type of the solutions we are going to be considered as a diluted acids. Next one, see some more information related to dilute and concentrated acid. Dilute acids, small amount of acid per unit volume. It means in the particular volume of the container or volume of the water we are having very few amount of the acidic substances. So that type of the solutions we are going to be considered as a diluted acids. So concentrated acid means we already discussed in the previous slide, no? So very large amount of the acid substances present in the water is called as a concentrated acids. Large amount of the acid per unit of volume is called as concentrated acids. So this is the diluted acid. In the figure you are observing, we are having same quantity of water, right? We are having in two beakers along with the water. The level of the water in the both two beakers are same, but see here the red bubbles or the red particles what we are observing on the display. So these are the acidic substances. In diluted acid we are having very less amount of the acidic substances, whereas in the concentrated solution we are having huge amount of the acidic substances. And next one is the gap between the particles existing in these two. The gap between the particles and acidic substances is very tightly packed in the concentrated solution, where in the diluted solution the particles are randomly moving from one place to another place. It means it have maximum amount of the intermolecular space. Okay, see here one more same definition related to concentrated and diluted acid. Acids solutions used in the laboratory may be concentrated or diluted. Concentrated acids containing large amount of pure acid dissolve in water, while dilute acids contain small amount of the acid in water. These things we already discussed in the previous slide, right? So take one example. Two bottles of HCl have concentration of 5 moles and 0.5 moles. Which is more concentrated, and explain. So this is the first image and second image. The first bottle is having 5 moles of the concentration of the HCl, and second bottle have only 0.5 moles of concentration. So which is the strongest or concentrated acid here? Obviously the first bottle is having more concentration, because we're having very large amount of the acidic substance in the first bottle. The next type of the classification of acids is organic and inorganic acids. Acids are classified in different ways as given below. The second type is based on their sources. Acids present in plants and animals, it means living things, or organic acids. For example, acetic acid. Acetic acid is a one type of the organic acid. Organic acids means the acid which is obtained by the living organisms like plants, birds and animals. What we are getting the acidic substances from the living organisms, that type of the acids we are going to be considered as a organic acid. Inorganic acids means the acid which is prepared in the laboratory conditions, in the particular laboratory conditions with the help of the rocks and minerals, are called as a inorganic substances, inorganic acids. For example, HCl, H2SO4 and nitric acid, it means HNO3. The next type of the classification is strong acids and weak acids. Strong acids and weak acids. So these strong acids and weak acids is classifying on the basis of the amount of hydrogen ion dissolved in water. When we dissolve any acidic substance in water, if it completely dissolves in water, it means it will be releases the maximum amount of the hydrogen ions. For example, if I dissolve HCl in water, if it soluble or completely dissolve in water, obviously it should be releases the maximum amount of the hydrogen ions. So if it releases the maximum amount of hydrogen ions, so then that type of the solutions we are going to be considered as a strong acids. So strong acids are nothing but the a strong acid is the one in which all the acidic molecules becomes ion in water. It means what we are dissolving the acidic substance that is completely dissociated and provides hydrogen ions. So these acids are called as a strong acids. Some of the examples for strong acid is hydrochloric acid, sulfuric acid and nitric acid. See here, so these are the acidic substances. These all are the acidic substances we are going to dissolve in water. Once we dissolve the acidic substances in water, it releases the maximum amount of the hydrogen ions, H plus ions. So these type of the substances or these type of the solutions we are going to be considered as a strong acids. Next one is weak acid. So weak acid is obviously exactly opposite to the strong acid. What happens in strong acid? The maximum amount of the acidic substance is completely dissolved in water. If it completely dissolved in water means obviously it will be releases the maximum amount of the H plus ion. But in weak acids, in the weak acid, we are dissolving the acidic substances. If it dissolve partially or incompletely, then it will be releases the very less amount of the hydrogen ions, very less amount of the hydrogen ions. A weak acid is the one in which only few acid molecules become ions in water. It means all the acidic substances come, all the acidic substance is not completely dissolved in water. If it partially dissolves in water means it releases the very few amount of the H plus ions. So these type of the acids we are going to be considered as a weak acids. Examples for the weak acid is acetic acid, citric acid and carbonic acid. See here, what happens, these all are the acidic substances. Again we are going to be dissolved in water. Once we dissolve the acidic substances in water, if it releases very less amount of the H plus ions, very less amount of the H plus ions, so that type of the solutions we are going to be considered as a weak acids. See here, some of the examples are given for strong acids and weak acid. The first one is hydrochloric acid. These are all strong acids. Hydrochloric acid. Next one, perchloric acid. Next, hydrobromic acid, nitric acid, sulfuric acid, hydroiodidic acid, and these all are the some examples for strong acid. And in the second column we are having weak acids. So first one is nitrous acid, formic acid, acetic acid, hydrocyanic acid, hydrogen sulfide, and next one is hydrofluoric acid. So these all are the examples for weak acids. Okay, now differentiate between the strong acids and weak acids. So how you are going to be differentiate between the strong acid and weak acids? When acids is acidic substance is dissolved in water, if it completely dissolve in water and it releases the maximum amount of the hydrogen ions, then that type of the solutions we are going to be considered as a strong acid. If it dissolves partially and releases the very few amount of the H plus ions, then that type of the solutions we are going to be considered as a weak acids. So see here, some differences are there. In the strong acid, the pH value of the strong acid is very less, lower pH value, where in weak acids higher pH value, and second difference is high degree of ionization. In weak acids, low degree of ionization. And next one is has higher concentration of H plus ions. Higher concentration of H plus ions means it releases the maximum hydrogen ions. In weak acids, the acidic solution is partially dissolve in water or partially dissociate in water, so it releases the very few amount of the H plus ion. It means it has lower concentration of H plus ions. So examples for the strong acids are hydrochloric acid, nitric acid and sulfuric acid. In examples for the weak acids are ethanoic acid, carbonic acid and sulfurous acids. The next important concept is basicity of acids. Basicity of acids means, in simple words we can define a basicity of acid is the number of hydrogen ions present in the acidic compounds are called as a basicity of acids. So basicity of acids means the number of hydrogen ions present in the acidic compounds are called as a basicity of acids. The basicity of an acid refers to the maximum number of hydrogen ions produced by molecule of the acid in aqueous solution. See here some examples are given. Again we are classifying the basicity of acids based on the number of hydrogen atoms present in the compound. For example, if compound having one hydrogen atom, we call it as a monobasic acid. Two hydrogen atoms, dibasic acid. Three hydrogen atoms, tribasic acid. See some examples are given here. First one is hydrochloric acid. So in hydrochloric acid, what is the formula for hydrochloric acid? HCl. How many hydrogen atoms are present in HCl? Only one hydrogen atom. Only one hydrogen atom is present means it is a monobasic acid, and it forms a H and Cl. When it decomposes, it will form a H and Cl minus. It means one hydrogen atom will be produced when we dissolve the hydrochloric acid in water. The next one is nitric acid. The formula for the nitric acid is HNO3. Again here we are having one hydrogen atom. One hydrogen atom means that is nothing but a monobasic acid. Next, third one is ethanoic acid. In ethanoic acid also we are having one hydrogen atom, so that is also the best example for monobasic acid. And the fourth example is sulfuric acid. So see the formula of sulfuric acid, H2SO4. H2SO4 means how many hydrogen atoms are there here? So two hydrogen atoms are there. So two hydrogen atoms are there means obviously it is a dibasic acid. It means it releases the two hydrogen ions when it dissolves in water. And third one, last one is phosphoric acid, H3PO4. So how many hydrogen atoms are present in phosphoric acid? 3 hydrogen atoms. If 3 hydrogen atoms are present in the acidic compound means we call it as a tribasic acid. So basicity of acid is nothing but the number of hydrogen atoms present in the acidic compounds are called as a basicity of acids, or the number of hydrogen atoms produces when the acidic substance is dissolved in the water are called as a basicity of acids. And these basicity of acids we are going to be classified on the basis of the number of hydrogen atoms present in the acidic compound. If one hydrogen atom is present, means we call it as a mono basic acid. Two hydrogen atoms are there, means dibasic acid. Three hydrogen atoms are there, means tribasic acid. See here the same examples. It is the number of ionizable H plus ions present in an acid. HCl is a monobasic. It ionizes to produce one hydrogen ion. When HCl is dissolved in water, what happens? It releases the 1H plus ion. Next one, in sulfuric acid, H2SO4 is a dibasic acid. It ionizes to produce two hydrogen ions, H2SO4. Here two hydrogen ions are produced when it dissolves in the water. Next, phosphoric acid. In the phosphoric acid, it's the best example for tribasic acid. It ionizes to produce three hydrogen ions. Okay, so these are the three examples for monobasic acid, monobasic acid, dibasic acid, and tribasic acids. The next concept is preparation of acids. Preparation of acids. There are several methods for preparing acids. Some of them are: first one, synthetic method or direct method. So in synthetic method, acids are prepared by the direct combination of elements. By the direct combination of the elements, we are going to be prepare the acidic substances. For example, when hydrogen and chlorine combine together, it forms a HCl. When hydrogen ions or hydrogen atoms and chlorine atoms are combined together, elements are combined together with the help of the electric spark. With the help of the electric spark, we will get the hydrochloric acid. So this is the direct or synthetic method. In direct and synthetic method, we are going to combine the direct elements by passing the electric spark. We will form the acidic substances or acidic solutions. See here one more example. The sulfuric acid is formed by the combination of sulfur, so when sulfur is combined with the oxygen, it forms a sulfur dioxide. This is also one of the best example for synthetic method. Synthetic method is also called as a direct method. In direct method or synthetic method, we are going to add directly elements. So sulfur and oxygen combined together, it forms a sulfur dioxide. When this sulfur dioxide is again combined with the oxygen, it forms a sulfur trioxide. So take this sulfur trioxide and dissolve in water, or it combines with the water. When it combines with the water, means it forms a sulfuric acid, that is nothing but a H2SO4. So how we can obtain the H2SO4? By the combination of sulfur and oxygen. By the combination of sulfur and oxygen, we get sulfur dioxide. Again this sulfur dioxide we are going to combine with the oxygen, we get a sulfur trioxide. This sulfur trioxide, if we dissolve in water, it forms a sulfuric acid. So this is the first method, that is synthetic method or direct method. In this method, we are going to combine direct elements and form a acidic substances. In the second method, we are having one more method, by dissolving acidic oxides in water. When we dissolve some acidic oxides in water, it gives acids. These oxides are called as acidic oxides. For example, we already discussed in the previous slide, sulfuric trioxide. Sulfuric trioxide is dissolved in water. It gives H2SO4. It means sulfuric acid. reacts with a reacts with water to produce salts. Directly we are taking the acidic oxides. So these are the acidic oxides are the substances we are going to add directly to the water. We get a acids. For example, sulfuric trioxide, we already discussed in the previous slide. Sulfuric trioxide dissolve in water, we get a sulfuric acid. Here see the equation of the sulfuric acid, SO3. SO3 means sulfuric trioxide. When it combines with the water, H2O, it forms a H2SO4. So this is the formation of the sulfuric acid. Similarly, we are having one more example, that is carbon dioxide. When carbon dioxide is dissolved in water, when carbon dioxide dissolve in water, it forms H2CO3. H2CO3 means carbonic acid. When carbon dioxide is dissolved in water, it produces carbonic acid. So this is also the example for the formation of the acid by the direct dissolving of acidic oxides. See some more information about the acidic oxides. Oxides of non-metals. Oxides of non-metals. For example, in the previous slide we took no carbon dioxide. Carbon is one of the non-metal. Acidic oxides are often gases at room temperature. Reacts with the water to produce a acids. It means acidic oxides. When acidic oxides react with the water, or when it dissolves in the water, it produces the acids. For example, we already discussed this one, sulfuric trioxide. When we dissolve in the water, it forms a sulfuric acid. Next one, react with the base and alkalis to produce salt. For example, carbon dioxide. When carbon dioxide is combined with a sodium hydroxide, it forms a sodium carbonate and water. Sodium carbonate and water. The next one is a react with the basic oxides to produce salts. So these are the few of the information related to acidic oxides. Now come to the most important concept of this chapter, that is the reaction. The reaction of acid with the different components. So see here reaction types. The first one, an acid. When acid is combined with a base, what we will get? Salt and water. So this is the first type of the reaction. In second type of the reaction, when acid is combined with a metal, it forms a salt and hydrogen ion. This is the most important reaction. Whenever the acid substances combined with a metal or reacts with a metal, it always forms salt and with the liberation of the hydrogen gases. And third one is when acid is combined with a metal oxides, again it forms a salt and water. When acid combined with the metal, it forms salt and hydrogen. When same acid is combined with the metal oxides, it forms a salt and water. And fourth type reaction is when acid combined with the carbonates, it forms salt and water, carbon dioxide. When acid combined with a carbonate, it forms three product. First one is salt, second one is water, and third one is carbon dioxide. Later we will discuss all these things. First one, next last one is a when acid is combined with a hydrogen carbonate, it forms a salt and water, carbon dioxide. Salt, water and carbon dioxide. Okay, see the first type of the reaction. So this type of the reaction you already studied in the first chapter. When acid is combined with a base, when acid is combined with a base, it forms a salt and water. So when acid is combined with the base, it forms salt and water. So these type of the reactions, we call it as a neutralization reaction. See here, the first type of the reaction, that is when acid is combined with the base, it forms a salt and water. So this is the general equation of the reaction. Bases are also called as alkalis. When alkalis are combined with the acids, it forms a salt and water. Some of the examples are given here. Acid neutralizes the base. Acid neutralizes the base. That's why we call it as a neutralization reaction. Neutralization reaction always produces salt and water. Neutralization reaction always produces a salt and water. See here, some of the examples are given. When HCl is combined with a NaOH, hydrochloric acid is combined with the sodium hydroxide, what it forms? Sodium chloride and H2O, NaCl and H2O. This is the first example. When sulfuric acid is combined with the sodium hydroxide, it forms a Na2SO4, Na2SO4 and H2O. Next one, HNO3, twice of HNO3. It means nitric acid is combined with a magnesium hydroxide. It forms MgNO3 and water. So all these are the salts. All these are salts, and remaining one more product is water, and these all are the bases, and these all are acids. So neutralization reaction means when acid is combined with the base, it forms salt and water. That's why all the neutralization reaction will produce a salt and water. No, second type of the reaction of acids with the metals. How the acids will be react with the metals? When metals react with the acids, or acid reacts with the metals, it always form salt and hydrogen gas. The hydrogen gas will be get liberates. This is the most important question. What happens when acid is combined with the metals? Whenever the acid is combined with a metal, it forms salt and the liberation of gas. What type of the gas will be released, or which type of the gas will be released when acid is combined with a metal? Obviously the gas is nothing but a hydrogen gas. Okay, see here, the metal dissolves and effervescence occurs. The gas extinguishes a burning of splint with a pop sound. So when the metal is react with acid, it produces a pop sound, and it produces the two most important components, that is salt and hydrogen gas. See here, some of the examples are given for the reaction. Magnesium, when magnesium is react with the hydrochloric acid, it forms a magnesium chloride. Magnesium chloride is nothing but it's a one type of the salt, and hydrogen will get liberates. Okay, and next one, calcium is combined with the, or when calcium react with the sulfuric acid, what it forms? Calcium sulfate. Calcium sulfate is nothing but a salt, and hydrogen gas will be get liberates. And third one, when zinc reacts with a sulfuric acid, when zinc react with a sulfuric acid, it forms a zinc sulfate, and hydrogen gas will be get liberates. See here some more examples. When the metals combined with the acid, it forms a metal salts. and hydrogen. For example, metal salts means if I am taking sodium as a metal means sodium with a salt, and magnesium salts, zinc salts. For example, listen here, magnesium is also one type of the metal. When it combines with a chlorine, hydrochloric acid, what it forms? Magnesium chloride. So this is the one type of the metal salt. We are using the magnesium as a metal. From the combination of the magnesium metal combining with the hydrochloric acid, we get a magnesium chloride. Next one, aluminium. When aluminium is combined with the or reacts with the same HCl, hydrochloric acid, it forms a aluminium chloride along with the hydrogen gas. So aluminium chloride is also one type of the metal salt. So when the metal reacts with acid, it always form a metal salt, or commonly we call it as salts and hydrogen gas. See the next one. What happens when acid is combined with the metal oxides? When acid is combined with the metal oxides, it forms a, see with the example, when sodium hydroxide is combined with the hydrochloric acid, it forms a sodium chloride and water. When potassium hydroxide combined with the sulfuric acid, it forms a potassium sulfate and water. Okay. Next one, the reaction of acids with the carbonates. So see the general form of the reaction. What happens when acid is combined with the carbonates? When metal carbonates react with acids, it forms a salt, water and carbon dioxide as a liberated gas. So see the general reaction once again. When metal carbonates react with the acid, it forms salt, water and carbon dioxide. See here some examples are given. Reaction of acids with the carbonates. All the carbonates react with acid to form salt, carbon dioxide and water. It is an example of neutralization reaction. So when carbonates react with the acid, it forms a salt, carbon dioxide and water. For example, few of the examples are given here. First one, calcium carbonate. When calcium carbonate is combined with the hydrochloric acid, what it forms? Calcium chloride, carbon dioxide and water. Similarly, second one, sodium carbonate. When sodium carbonate treated with or react with the sulfuric acid, it forms a sodium sulfate, carbon dioxide and water. And third example is when copper carbonate combined with a nitric acid, it forms a copper nitrate, carbon dioxide and water. It means whenever the metal carbonates react with the acids, it always form three most important products like salt, carbon dioxide and water. Okay. Hydrochloric acid produces the chlorides, nitric acid produces the nitrites, sulfuric acid produces the sulfides. Next one, again this is also the same thing, that is reaction of acids with the carbonates. The metal dissolve and effervescence occurs. The gas forms a white precipitate with the lime water. Here you are observing, when metal is react with the metal carbonates or react with the acids, it forms a precipitation, white precipitation and with the lime water. This is also some examples for the same type of the reactions. Here magnesium carbonates combining with a hydrochloric acid, that is HCl. What it forms? Magnesium chloride, water and carbon dioxide. When magnesium carbonate combined with a hydrochloric acid HCl, it forms a magnesium chloride MgCl2 along with the water H2O and carbon dioxide. And see the next one example, calcium carbonate CaCO3. When calcium carbonate combined with a sulfuric acid means H2SO4. When CaCO3 combined with the H2SO4, it forms calcium sulfite. Calcium sulfite along with the water and carbon dioxide. It means whenever the acid is combined with the carbonate, it always forms what it forms? Carbonates, next one water and carbon dioxides. See here some more information regarding the reaction of metal carbonates. Adding a metal carbonates or a metal hydrogen carbonate to an acid produces salt, carbon dioxide and water. So when acid is combined with a metal carbonate, it always forms salt, carbon dioxide and water. So here's two examples are given. Hydrochloric acid, it is combined with the calcium carbonate, it forms a calcium chloride, carbon dioxide and water as a products. Similarly, when hydrochloric acid is combined with the sodium hydrogen carbonate, it forms a sodium chloride, carbon dioxide and water. Next one, the last concept of the acid, that is the uses of acid. Okay, see here the first one is, what is this first one? Sulfuric acid, H2SO4, carbonic acid, benzoic acid and ethanoic acid, nitric acid. So what are the uses of acids? Why we need the acids in our day-to-day life? See the first one, uses of hydrochloric acid, that is HCl. What are the uses of HCl? HCl is used in the manufacture of glues. Next one, to purify common salt, in the preparation of glucose and chlorides, for bleaching in textile industries. So these are the few uses of hydrochloric acid. The second acid is sulfuric acid. See some important uses of sulfuric acid. Sulfuric acid is used in the manufacturing of fertilizers, in the manufacturing of the paint pigments, in the manufacturing of the detergents, in the manufacturing of synthetic fibers. The same sulfuric acid is also used as a cleaning substances of metals, in the manufacturing of plastics. So the same sulfuric acids were using in car batteries, again were using in the manufacturing of other chemicals also. So these are the some of the uses of sulfuric acid. Next one, nitric acid. See the next one, that is nitric acid. Nitric acid has important commercial applications. It is used in the manufacture of important fertilizers such as ammonium nitrate and basic calcium nitrate. So this is the first use. Second one, the same nitric acid is used in the manufacture of explosives like TNTs, RDX and nitroglycerins. And third use of the acid is rockets, in the rocket propellants are used as a nitric acids as an oxidizer. And thus manufacture, in the manufacturing of the artificial silk, dyes and plastics, and nitro derivatives of organic compounds, in the manufacturing of the silks, dyes and plastics also we are using nitric acid. And the next one is to purification of gold and silver. In the purification of gold and silver also we are using nitric acids. And the next use is in the purification of silver nitrate, which is used in the making of photographic films and medicines. The last use of nitric acid is as an important reagent in laboratories. So these are the some of the uses of nitric acids. See the next one, that is phosphoric acid. So what are the uses of phosphoric acid? Phosphoric acid is one of the most widely known and used acid. This acid is also known as orthophosphoric acid and is an mineral acid. It used for removal of dust. With the help of the phosphoric acid we can easily remove the dust. Second one, it is used in the process of food. And third one, it is used in the medical field also. And the fourth use is phosphoric acid is used as the electrolyte in phosphoric acid fuel cells. And the last one is it is used as a catalyst in the hydration of alkanes to produce the alcohols. So these are the some of the uses of phosphoric acid. So the next one, that is citric acid. So what are the uses of citric acid? You already know the uses of citric acids. It is used as a food and drink, to preserve the flavoring agent, household cleaners, and next one cosmetics, next one wash cleaners. It means in the household cleaners it is used as a kitchen substances, bathroom sprays, shampoos, body washes, next nail polishes, hand soap and other cosmetic products. So citric acids are used in all these things. The next acid is boric acid. Boric acid can be used as a antiseptic for minor burns or cuts. Boric acid was first registered in USA as an inspected in 1948 for control of many insects. Boric acid is used in the production of glasses in LED flat panel displays. So in LEDs we are using the boric acid. Next one, boric acid is used in the pyrotechnics to prevent the amide forming reaction between the ammonium and nitrates. So just revise what we learned in the today's class. The most important concepts are the properties, definition of acids, properties of acids, and examples of acids, and how the acid will be react with the metals. When acid react with the metal, it forms a salt and hydrogen gas. Second one, when the same acids react with the metal carbonates, it forms a salt, water and carbon dioxides. When it reacts with the bases, when acids are react with the bases, it forms a salt and water. So these are the reactions of acids. Acid react with a metal, it forms a salt and hydrogen gas. When acid react with a metal carbonates, it forms a salt, carbon dioxides and water. When same acid react with the metal oxides, it forms a salt and water. When acid reacts with the alkalis means bases, it forms a salt and water. So this is all about the acids. In the next class we are going to discuss about the bases, definition of base and properties of bases, examples for bases, how the bases will be formed and acidity of the bases. Okay, and how the bases react with the acids, metals, non-metals and metal carbonates. In the next class we are going to discuss about all these things. Till then, be happy, have a nice day. Thank you.